So yesterday we did the laws of simple pendulum, right?
Yes, sir. Yes, sir. We did till simple pendulum in the lift, sir.
Oh, that is also done, eh?
Yes, sir. T3 equal to T naught and T4 equal to infinity.
Okay, fine. T4 is equal to infinity means it doesn't oscillate at all.
Yes, sir.
So in the absence of, because net acceleration due to gravity becomes zero,
Yes, sir.
in the absence of gravity it does not oscillate. That is the meaning of
Yes,
it.
sir.
Okay,
Yes. Yes, sir.
fine. So we'll do another simple harmonic oscillator.
Yes, sir.
What is it number, ma? Ma, Anaga.
Yes, sir. Sir, it is 5-1, sir. We did till 5-1.
5-1.
Yes, sir. Simple pendulum in the lift.
Okay, fine. A pendulum of length 20 centimeters
Yes, sir.
is in a trolley 5-2. Okay,
Yes, sir.
is in a trolley which is sliding down, which is rolling down. Okay, a smooth inclined plane
Yes, sir.
of inclination 60 degrees.
Yes, sir.
What will be its time period?
Yes, sir.
So this is what is given in the problem.
Yes, sir.
Here is the inclined plane. So this is the trolley is rolling down the smooth inclined plane, AB of inclination 60,
Yes, sir.
and the length of the pendulum is given as 20 centimeters. Theta is 60 degrees. You know,
Yes, sir.
this is mg, correct?
Yes, sir. Downward.
This is mg
MG
cos
cos.
theta, mg sin theta.
Yes, sir.
So the normal component of g is how much? The component of g normal to the plane is g cos theta, correct?
Yes, sir.
So
Yes,
formula
sir.
for time period will become 2 pi root of L by normal component of g to the plane. Therefore, 2 pi root of this mg sin theta will make the
Yes.
trolley to roll down the plane,
Yes, sir.
whereas mg cos theta is the normal component. Of
Yes,
course,
sir.
is a normal reaction.
Yes, sir.
Therefore, the formula for time period will now become 2 pi root of L by G cos theta. Important concept.
Yes, sir.
So if you substitute the values, it is L is
20, sir.
0.2 by 10 into cos 60,
1/2.
1 by 2. 1 by 2, sorry.
Yes, sir.
So this is 2 pi into root of 0.2 into 0.2.
Yes. Yes, sir.
So 0.4 pi seconds.
Yes, sir.
1.256 seconds.
Yes, sir.
This is also important concept. Pendulum in a
Yes, sir.
trolley rolling down the lift, rolling down the inclined plane.
England. Yes,
Hmm.
sir.
One more. Completed?
Yes, sir. Yes, sir.
A simple pendulum of length L, a simple pendulum of length L
Yes, sir.
has a time period t seconds. Has a time period t seconds. A nail is located. A nail is located
Yes, sir.
at a distance of a nail is located at a distance of
Yes,
3L
sir.
by 4 from the point of support. From the point of support.
Yes, sir.
Find the time after which
Yes, sir.
find the time after which the pendulum returns back to A. The pendulum returns back to A
Yes, sir.
after it is released.
Yes,
After
sir.
it is released.
Believe. Yes, sir.
So here what happens, ma?
Sir, here the pendulum is released. It comes to A, that is extreme position.
Correct only. But after how much time it comes back to extreme position means how will you do this? From here to O
Yes, sir.
and back from O to A.
Yes, sir.
It is half of the time period.
Yes, sir.
If the nail is not there, the pendulum would have gone to B.
Yes, sir.
Kada?
Yes, sir. Yes, sir.
But because of nail, only this
Oh, it
part
till
of the
O.
pendulum will be swinging.
Yes, sir.
3/4 of the length of the pendulum will be stopped by the nail.
Yes, sir. Yes, sir.
only 1/4 of the pendulum, length of the pendulum will be swinging.
Yes, sir.
Remaining 3/4 of length of the pendulum is prevented from swinging. So this nail will act as support for this L/4 length.
Yes, sir.
Have you understood that?
Yes, sir. Understood, sir.
Vertical oscillate
Three-fourths. Yes, sir.
3/4 of the length దగ్గర ఒక nail పెట్టావు.
Yes, sir.
అంటే from S to that N part, it is
Yes, sir.
prevented from swinging.
Yes, sir. It
Only
is
the
fixed.
last 1/4 part is swinging.
Yes, sir.
So you must calculate the time taken by it from O to B
Yes, sir.
and
O
from
to
B
A.
to O.
Yes, sir.
Now T dash by T is root of L dash by L kada?
Yes, sir.
What is L dash here?
L/4. The remaining length.
So T dash is T by 2. Avuna?
Yes. Yes, sir. Yes,
This
sir.
complete oscillation ki.
Yes, sir.
For complete oscillation,
From O to A, sir.
with length L/4.
Yes, sir.
But it is from OB to BO. So ikkada TOB and BO will be T dash by 2 only.
Yes, sir.
Means T dash is T by 2 by 2. So how much?
T/4.
T by 4. So what is the total time taken by it to come back to A to O and O to A T by 2,
Yes, sir.
and O to B and B to O T by 4.
T/4.
So it should be
3T/4.
3T by 4. Okay,
Yes, sir. Yes, sir.
you can write the string of the pendulum, the portion of the pendulum of length 3L/4,
Yes, sir.
the portion of the simple pendulum of length 3L/4
Yes, sir.
is prevented from oscillation. Is prevented from oscillation by the nail. ఇంక ప్రాబ్లమ్
Yes.
కాన్సెప్ట్ కింద చెప్పేస్తున్నాను.
Yes, sir. Yes, sir.
నెక్స్ట్ ఫైవ్ ఫోర్.
Yes, sir.
Two pendula
Yes, sir.
start oscillating together.
Yes, sir.
Their lengths are 1.44 meters
Yes, sir.
and 1 meter.
Yes, sir.
After how many number of oscillations? After how many number of oscillations?
Yes, sir.
They swing together. After how many number of oscillations? They swing together.
Yes, sir.
So let us assume that at t is equal to 0, they are swinging together. Okay.
Yes, sir.
Now, in after t seconds, the first pendulum made n oscillations, second pendulum made n2 oscillations.
Yes, sir.
Such that there will be definitely, since lengths are different, time
Yes,
period will be
it will
different.
be different.
Hence, there will be at least one oscillation should be
Extra.
differing between
Yes, sir.
the two pendula
Yes, sir.
for them to swing together.
Yes, sir.
Therefore, we have the formula for time period is equal to T by N is equal to 1 by 2 pi into root of L by G. Correct?
Yes, sir.
So from that we can write N into T will be constant, correct?
Yes, sir. Yes.
Say for the same time they are swinging.
Singing. Yes, sir.
So T is constant.
Yes,
Therefore,
sir.
I can write N1 T1 should be equal to N2 T2.
Yes, sir.
So N into T1 is N plus 1 into T2. Means N plus 1 by N is T1 by T2.
Yes,
According to
sir.
the first law, it is root L1 by L2.
Yes, sir.
So this is 1 plus 1 by N is root 1.44 by 1, that is 1.2. So 1 by N is 1.2 minus 1.2. So N is 10 by 2, that is after 5 oscillations. So first pendulum makes 5 oscillations. Second pendulum makes 5 plus 1, 6 oscillations. Again they swing together.
Yes, sir. Sir, for this type, we have to first assume t equal to 0, sir, every time.
Yeah, initially they start oscillating. Na?
Oh, okay, sir. Yes, sir. Okay, sir.
So initial means T is equal to 0.
Yes, sir. Okay, sir.
Already pendulum in the lift, I gave you one problem, I think, yesterday.
Yes, sir. Sir, we didn't do any problem, sir. We did ratios.
Okay.
I mean, new one equal to. Yes, sir. We did. Problem we didn't do, sir. You gave some
Okay, you
formula.
take a pendulum of time period, say 2 seconds.
Yes, sir.
Acceleration, you take it as some 1.2 meters second to the power of minus 2.
Yes, sir.
2.2 you put.
Yes, sir.
Okay.
Yes,
Because
sir.
the lift is accelerating upwards.
Yes, sir.
T1 by T naught is root of G by G plus A. Antena?
Yes, sir.
Ante? Root of 10 by 12.
Right. Yes, sir.
9.8 in fact.
Okay, sir.
Or you take G is equal 10, 9.8 by 12. Okay. So T1 will be 2 seconds into root of 98 by 120.
Yes, sir.
2 into 49 by how much? 30 into 4,
Yes, sir. Oh, yes.
15 into 8, 40 into 3. Antena?
Yes, sir.
Yeah, 4 into 30.
Oh, yes.
So this is 2 15s. So T1 will be 2 into root 49 is 7.
7,
By root 4 is 2.
2.
15 is nearly 4. Nearly 4.
Yes, sir.
So 7 by 4 means 4 ones. 4 6, 4 6, 1.6, 6.4. 4 1.7, 6.8. So 1.75 seconds. When the pendulum is ascending, when the pendulum, when the lift is ascending, sorry, when the lift is descending, then
Yes, sir.
T2 by T naught is root of G by G minus A, root of 9.8 by 7.6.
Yes, sir. Yes, sir. T2
98 by 76.
76.
So 249s, 238s.
7.
Nearly 7 by 6.
Yes, sir.
So 7 by 6 and 6.2 and 4.
One. Yes, sir.
Yeah, 1 point.
Sir, 1 point.
2
Yes, no, sir. It will
1.1
1.1. Yes, sir. 1
into
point.
2 అంటే 2.2 seconds.
Yes, sir. Sir, exam లో ఇక్కడ √6 కి ఎగ్జాక్ట్ వాల్యూ రాయాలా సార్ అప్రాక్సిమేట్
వాడు
తీసుకోవాలి
జనరల్ గా అలాంటప్పుడు వాల్యూ ఇస్తుంటాడు.
ఓకే సార్ ఓకే
He will give the value. ఓకేనా?
yes sir yes sir
Then one more is there, na? That is
yes
sixth one, loaded spring oscillations.
yes sir
So here is a rigid support and we suspended a spring with a load M attached at the free end.
yes sir
Imagine here is a scale. This is called natural length of the spring.
yes sir
And when you pull it down and release, it will go up to some point A, say some 5 centimeters. And then once you pull it and leave it, from A through O, it goes up to B. Again from B, it comes back to A. Like this, it makes up and down oscillations
yes sir
about the mean or equilibrium
Equilibrium.
position. So
Yes, sir.
here, the load attached, because it's moving along straight line, it will be in
linear asset
linear simple harmonic motion with acceleration A, of course, equals to omega square y, because the displacement is in vertical plane.
yes sir
So here we got definition of simple harmonic motion. F is equal to minus ky, kada?
yes sir
K is the force
Spring
constant or spring constant.
yes sir
F is equal to ma, that is minus ky.
yes sir
A is equal to minus k by m into y.
okay sir
So if you compare these two, you will be getting angular velocity of the loaded spring oscillations. Capital M kada vesam? Yeah.
yes sir
Angular velocity of the loaded spring oscillations comes out to be omega is equal to root of k by m.
yes sir
Therefore, time period is equal to 2 pi by omega. Avuna?
yes sir
So So 2 pi root of m by k.
Yes, sir.
And frequency is the reciprocal of time period. So it is 1 by 2 pi into root of k by m.
Yes, sir.
So this is another simple harmonic oscillator. Okay.
Yes, sir.
Then in this, suppose we have two springs of spring constants k1 and k2.
Yes, sir.
They are connected in series. There is another arrangement in which the two springs are connected in parallel.
Yes, sir.
Suppose the extension produced in the first spring is y1 and the extension produced in the second spring is y2. Then total extension produced in both the springs can be written as y1 plus y2.
Yes, sir.
Here these two springs k1 and k2 are in parallel, and the restoring forces in the two springs are F1 and
F1.
F2. So the
Yes.
total restoring force when they are connected in parallel, because here the extension remains same for both.
Yes, sir.
When springs are connected in parallel, y1 will be equal to y2 will be equal to y.
Yes, sir.
Here F is same, load is same. So y is equal to F is equal to ky kada.
Yes, sir.
So y is equal to n raichappudu
F by K, sir.
so ఇక్కడ y is the total extension of both the springs. Therefore it
Yes.
becomes by F by Ks.
Yes,
F
sir.
equal to F into 1 by K1 plus 1 by K2. Antena?
Yes, sir.
Means what will you get? The effective spring constant of two springs connected in series is
Yes.
1 by Ks is equal to 1 by K1 plus 1 by K2.
Yes, sir.
Therefore, Ks will be K1 K2
K1.
by K1 plus
K1.
K2.
Yes, sir.
Coming to this, F is equal to Kp into Y. Kp is effective spring constant of both.
Yes, sir.
Is equal to K1 into Y plus
K2.
K2 into Y. Therefore, the effective spring constant comes out to be here
K1 plus K2.
K1 plus K2.
Yes, sir.
So, what is the time period of oscillation of these two springs in series? 2 pi under root of
L by G.
m by k, kada?
Yes, sir. Yes, sir. K1 plus K2.
m by k1 k1 k2.
Yes.
K place లో k1 k2 by k1 plus k2 కదా రావాలి.
Yes, sir.
So 2 pi into m by k1 k2 by k1 plus k2. Okay?
Yes, sir.
And for this, the time period when they are connected in parallel, 2 pi root of m by k1 plus k2. Avuna?
Yes, sir. Yes, sir.
So if you get the ratio of these two time periods, Ts by Tp. చెప్పేమొస్తుంది? చెప్పాలి ఎంతసేపా?
Sir, yeah, K1 plus K2. K1.
చేయటం లేదు నువ్వు, చేయకుండా చెప్పేస్తున్నావు.
Yes, sir.
చేయాలి, పేపర్ మీద పెన్ను పడాలమ్మా.
Yes, sir.
కరెక్టేనా? Ts by Tp 2 pi into m multiplied by k1 plus k2 by k1 k2 divided by 2 pi into m by k1 plus k2. ఆ k1 plus k2 న్యూమరేటర్ లోకి వస్తుంది.
Yes, sir. Yes, sir.
Up root of k1 plus k2 whole square will become k1 plus k2 by root k1 k2. This is the ratio of time periods.
Yes, sir. Yes, sir.
Copy చేస్తావా?
Yes, sir. అయిపోయింది sir.
తర్వాత you are given a spring. You have connected a load to it. Its spring constant is k naught. Now this is cut into n equal parts.
Yes, sir.
So y becomes y naught by n. అంతేనా?
Yes, sir. Yes, sir.
For the given spring of constant k naught, extension is y naught. When it is
Yes,
cut
sir.
into n parts, it becomes y naught by n.
Yes, sir.
So k will be equal to, yes, it will be
Um,
how much it will be?
y by n, sir.
Y will be in the k is equal to f by y.
Yes, sir. Yes, sir.
K naught is mg by y naught.
Yes, sir.
So k is equal to f by y.
Yes, sir.
This is of course f. F by y naught by n. Therefore, we will get f is equal to n into k naught.
Yes, sir.
So you are given a spring, you have cut that into n parts, and each part will have a spring constant n into k naught. So the time period with the given spring, 2 pi root of m by k naught. Time period with one of these parts, 2 pi root of m by k.
Yes, sir.
That is 2 pi root of m by n into k naught. So what will happen? T naught by root n. Ona?
Yes, sir. Yes, sir.
So less than T naught. Means frequency is more than the original time frequency.
Yes, sir.
The frequency of oscillation will be more than the frequency of oscillation of the portion of the spring cut from the given spring will be more than the actual spring.
Yes, sir.
Ilati kuda you can expect some questions. Okay.
Yes, sir.
Then energy. Energy of simple harmonic oscillator. Yes, this is the pendulum, or this is the simple harmonic oscillator. Anything you can take.
Yes, sir.
This is the equilibrium position. Here is the extreme position. This is some other position at P. Okay. The displacement
Yes, sir.
here
Yes,
is x. So at P, the velocity of the simple harmonic oscillator is omega into root of r square minus x square. Antena?
Yes, sir. Yes, sir.
Then we have got the formula for force as F is equal to mr omega square. So this m omega square, it can be equated to kr. So k can be equated to m into omega square. So at P, the total energy of the simple harmonic oscillator at P will be partly potential, partly kinetic. Potential
Yes.
energy is given by half
Half
k
m.
x square.
Yes, sir.
That is half into m into omega square into x square. Antena?
Yes, sir. Yes, sir.
Because k is equal to m omega square, I said.
Yes, sir.
Kinetic energy is half mv square. That is half m omega square into r square minus x square.
Yes, sir.
That is the kinetic energy. So total energy, if you add them, it comes out to be half m r square omega square. Okay, ma?
Yes, sir. Yes, sir.
If you substitute omega is equal to 2 pi by t, then this will be equal to half m r square into 4 pi square by t square. Therefore, the energy becomes 2 pi square r square m, avuna?
Yes, sir. Yes, sir.
By t square. And 1 by t is frequency. So you
Yes,
can
sir.
also write it as 2 pi square mu square r square m. So this is the formula for energy of a simple harmonic oscillator.
Yes, sir.
Okay, ma? This is
Yes, sir.
all we have in oscillations topic.
Okay, sir.
You can take some more problems.
Yes, sir.
Have you noted down?
Yes, sir. Note it down.
Hmm. A particle is in SHM. A particle is in SHM
Yes, sir.
with time periods of 3 seconds and,
Yes, sir.
and 4 seconds when it is acted upon by the forces, when it is acted upon by the forces F1 and F2,
Yes, sir.
what will be their time period? What will be their time period if both these forces are supporting each other? Phone level. And opposing each other. If both these forces are supporting each other and opposing each other.
Yes, sir.
See, we have the formula F is equal to mr omega square.
Yes, sir.
Okay?
Yes, sir.
M and omega are same. So it can be also written as 4 pi square by t square mr. Anna?
Yes, sir. Yes, sir.
In place of omega is substituted 2 pi by t.
Yes, sir. Yes, sir.
This 4 pi square mr can be taken as common. So it will be c by t square.
Yes, sir. Sir, C is
C is a constant.
okay. Okay, sir.
So now F1 will be C1 by T1 square, C by T1 square. F2 C by T2 square. They are supporting each other means F1 plus F2
Yes, sir.
is equal to
F1 minus F2.
F1 plus
F
F2 is equal to F1 minus F2 na.
No, sir. No, no. Sorry.
Both are different.
Yes, sir. Yes, sir.
C by T1 square plus C by T2 square. You can call it as F.
Yes, sir.
So this can be written as F by T square, sorry, C by T square is equal to C into 1 by T1 square plus 1 by T2 square. Therefore, you are getting 1 by T square is equal to 1 by T1 square plus 1 by T2 square. So if you take LCM, T1 square plus T2 square by T1 square T2 square.
Yes, sir.
Therefore, the effective time period when the both the forces are acting, supporting each other is T1 T2 by root of T1 square plus T2 square. Antena?
Yes, sir. Yes, sir.
When standard formula గుర్తుపెట్టుకోవాలి.
Yes, sir. Okay, sir.
T1 into T2 12 by root of 3 square plus 4 square ante 5.
5. Yes, sir.
So 2.4 seconds.
Yes.
Opposing each other ante F is equal to yes, C by T square. Avuna?
Yes, sir. Yes, sir.
So F varies inversely
Yes,
as T square.
yes, sir.
Lesser the time period, more will be the
More
force.
is- Yes, sir.
So F1 minus F2. So this is C by T square is equal to C into 1 by T1 square minus 1 by T2 square.
Yes, sir.
Therefore, I get T is equal to T1 T2 by root of,
T1 square minus. Yes.
yeah, formula రాయాలి కదా,
Yes, sir.
T2 square minus T1 square.
Yes, sir.
T1 square minus T2 square రాదు, LCM తీసుకుంటే T2 square minus
Yes.
T1 square.
Yes, sir.
ఒకసారి రేషియో ఆఫ్ దీస్ టూ టైం పీరియడ్స్ అంటాడు. దీన్ని T Roman number 1 అందాం, దీన్ని T Roman number 2. So
Yes, sir.
T2 will be 4 3s are 12 by 16 minus 9 root 7 ante.
Yes, sir.
So if you are asked to find the ratio T1 by T2 will be root of T2 square minus T1 square by T2 square plus T1 square. Okay.
Yes, sir.
కాన్సెప్ట్స్ బాగా ఉండాలి మైండ్ లో.
Yes, sir. Yes, sir.
ఫార్ములే అన్ని తరోగా ఉండాలి.
Yes, sir.
అప్పుడు ప్రాబ్లమ్స్ వస్తాయి.
Yes, sir. Okay.
Yeah, one more problem we'll do.
Yes, sir.
Predict the acceleration velocity graph. Predict the acceleration A and velocity V graph of a particle of mass m in linear simple harmonic motion. He will give you 4 different graphs and you will be asked
Yes,
to put the correct graph.
Yes, sir.
So first of all, let us start with the equation y is equal to r sin omega t.
Yes, sir.
P r omega cos omega t A minus omega square R sin omega t. కదా?
Yes, sir. Yes, sir.
From this, sin omega t is A by R omega square. అవునా?
Yes, sir.
Cos omega t is V by R omega.
Yes, sir.
Now you square them and add them.
Yes, sir.
So sin square omega t plus cos
Cos square omega.
will be equal to A square
Yes, sir.
by R square omega to the power 4 plus
Plus V square
by
by
R
R
square
square.
omega square.
Yes, sir.
This should be equal to 1. Antena?
Yes, yes, sir.
So he wanted acceleration velocity graph.
Yes, sir.
Now from this, A square by R square omega square
Yes, sir.
plus V square is equal to R square omega square. R omega square.
Yes, sir.
R square omega square తీసుకొచ్చేద్దాం.
Yes, sir.
So here you are left with A square by omega square. కదా?
Yes, sir. Yes, sir.
Now you leave V square here. V square is equal to minus A square by omega square plus R square omega square. Right,
Yes,
sir?
sir. Yes, sir.
So you can rewrite this equation as V square is equal to minus 1 by omega square into A square plus R square omega square.
Yes, sir.
You compare it with y is equal to mx plus t.
Yes, sir.
Therefore, slope of this graph m will be 1 by omega square. Antena?
Yes, sir. Yes, sir.
Negative slope
Yes,
means
sir. Downward.
this is y, this is x. So I took v square on y-axis and a square on x-axis. This should be the graph. This is theta.
Yes, sir.
Excellent question.
Yes,
Saying
sir.
how much thinking you need, that you have to assess. I
Yes,
won't.
sir. Yes, sir.
Yeah. Just 1 minute.
Yes, sir.
So now you have maths class, na?
Yes, sir. Yes, sir.
Okay. So just one day wanted to have class tomorrow and day after.
Okay, sir.
Ba. బాగున్నావా? ఫైన్ వండర్ఫుల్. ఇక్కడరా ఏం లేదు, మన వామదేవ్ ఉన్నాడు కదా, వాడికి ఏవో ఎగ్జామ్స్ అవుతున్నాయట. రేపు ఎల్లుండి ఈ కెన్ హ్యావ్ ఎ క్లాస్ ఇట్ సీమ్స్. హీస్ ఫ్రీ. అదే నువ్వు ఏమైనా ప్లాన్ చేస్తావా అని అడిగి హీస్ ఫ్రీ ఓన్లీ ఎనీ టైం. రేపు అనగాకి 5:30 వరకు కెమిస్ట్రీ ఉంటుంది. అనగా విల్ హ్యావ్ క్లాస్, కెమిస్ట్రీ క్లాస్ will be there up to 5:30.
Yes, sir.
సో 4 to 5:30 ఏమన్నా వాడికి చెప్పమంటావా? ఫర్ వామ్దేవ్ ఫ్రమ్ 4 to 5:30 I'll tell you. 5:15 అనుకో. Okay. So tomorrow and day after I'll advise him to join your meeting at 4 o'clock.
Yeah.
Okay. ఇంకా లింక్ ఏం అక్కర్లేదు కదా, లింక్ పంపిస్తా. అని లింక్ ఈజ్ నీడెడ్. ఓకే. సరే. ఓకే ఫైన్. రైట్ బాయ్. రండి సరదాగా రోజు. ప్లీజ్ కమ్. ఓకే బాయ్. రైట్ అనగా అదే కన్ఫర్మ్ చేద్దాం సార్. క్లాస్ అడిగాడు కదా.
Yes, sir.
I wanted to inform you.
Yes, sir.
Okay, ma. Fine. Take care.
Okay. Thank you, sir. Good night, sir.
Bye.